Hello everyone, in this video I am going to explain how I connected all the components of my project and how they are used. First I used Arduino Uno as the main controller of the whole circuit, and all the components are connected to the power and ground lanes on the breadboard. And those lanes are connected to the Arduino so everything gets right power supply. First I connected the ultrasonic sensor, and its signal pin goes to a digital pin 9 on the Arduino, and the other two pins are placed on the breadboard lanes, and those lanes are connected to Arduino's power and ground. This sensor measures how far a user is from the system and distance between them, of course. Next I connected the servo motor. Its signal wire goes to the 6th pin on the Arduino, and the servo power wires are also connected to the breadboard power and ground lanes. The servo is what is used to open the and close the lid based on the distance detected and read by the sensor. After that I used a buzzer which is connected to pin 3 on the Arduino, and it is its negative side is connected to the ground lane on the breadboard. It gives warning beeps when someone is standing too close to the system. After that I also used an LED with a resistor which is connected to pin 4 and the ground lane through a resistor. This LED glows up when the system is in manual mode, and it indicates that the system is in manual mode, so the user knows which mode is active. For switching between modes, I connected a push button. One side of the push button goes to pin 2 and the other side goes to the ground lane. Whenever I press this button, it switches between automatic mode and the manual mode. After that, I used potentiometer, which is used when the system is in the manual mode. It is used for manual control, and its middle pin goes to the analog output pin on the Arduino, and the side pins are placed on the breadboard power and ground lanes. This lets the user to rotate the knob to control the servo angle manually whenever the manual mode is active. All components are placed nearly on the breadboard. The jumper wires connect each device to the correct Arduino pins. With all these connections working together, the system can sense distance, move the lid automatically, give warnings, and allows manual control whenever needed. Now I will show the output of my project, and when the system starts it begins in automatic mode. As you can see, the serial motor immediately starts showing the distance detected by the ultrasonic sensor, and as I move the hand or an object in front of the sensor, you can see the distance value update every 1 second. You can see the distance changes, and if the distance goes below 24 centimeters, as you can see, the serial motor prints that the user is too close. Wait, let's move on. Along with the time in seconds, at the same time the buzzer starts beeping. The beeping starts low for the first 3 seconds and then becomes medium between 3 and 8 seconds. And after 8 seconds it becomes very fast, and you can hear this change. Uh, when I move back to a safe distance between 25 to 80 centimeters, the buzzer stops. The serial motor now prints safe range, and the servo keeps the lid open at 90 degrees. And after that, if I move completely away more than 80 centimeters, the serial motor begins showing away time. As you can see, along with the distance, the timer continues to count how long the user has been far away. If the wait time reaches 300 seconds or 5 minutes, then the lid automatically closes for safety. Until then, the lid stays open and the buzzer remains off. And if the ultrasonic sensor detects an invalid reading, such as when the distance suddenly shows below 5 centimeters, as you can see, it is not counting below 5 centimeters. Yes, as you can see, if it goes below 5 centimeters, the serial motor prints invalid reading and the lid closes immediately. Now, when I press the button, as you can see, the mode switches to manual mode and the LED turns on. To show this change in the serial motor, it now prints manual mode along with the current servo angle. As I rotate As you can see, as I rotate the potentiometer, you can see the servo motor angle changing from 0 to 90 degrees, and the serial motor updates the angle once every second. Thanks to all, this is my project. And moving to the code starts by including the servo library and creating a servo object to control the lid. Then I defined all the pin numbers used in the project, such as the ultrasonic sensor on pin 9, the buzzer on pin 3 and the LED on pin 4 and the push button on pin 2. And after that the potentiometer on analog pin. I also created variables to store whether the system is in manual mode or in automatic mode, along with the timers for tracking how long the user stays too close or too far. And then I set two distance thresholds, one for the user when it is too close and which is below 25 centimeters, and the other when the user is far away, which is above 80 centimeters. Next is the ultrasonic distance function. This function sends a short trigger pulse and then measures the time taken for the echo to return. That time is converted into distance in centimeters. The program uses this distance throughout the system to make decisions. After that, there is also a buzzer pattern function which runs three different beep speeds: slow beep, medium beep, and the fast beep. And these speeds depend on how long the user has been standing too close to the sensor. After that, moving to the setup function. Inside the setup function, I initialize the serial motor, set the buzzer and LED as outputs, enable the internal pull-up for the button, and attach the servo to pin 6. And then set it the servo to 0 degrees so the lid starts in the closed position always. And moving to the main loop, it will run continuously the system. First, it checks if the button is pressed. If so, it toggles between manual mode and automatic mode. In manual mode, the LED turns on, the buzzer remains off, and the user can adjust the servo angle using the potentiometer. The system prints the angle every second, and none of the automatic feature runs in the mode. And in automatic mode, in manual mode, in automatic mode, the LED turns off, and the program reads the distance from the ultrasonic sensor. If the distance is invalid, such as less than 5 centimeters or more than 400 centimeters, the system closes the lid for safety and prints an error message. And if the user is very far away, meaning more than 80 centimeters, the lid stays open and a timer begins. If the user remains far away for 5 minutes, then lid automatically closes. This helps. And if the user comes too close, below 25 centimeters, another timer starts, which indicates that the servo will keep the lid open and the buzzer starts beeping. The beep speed increases depending on how long the user remains too close, starting slow and gradually increasing the beep after 8 seconds. This acts like a distance warning system to maintain safe interaction. When the user is in the normal range, which is between 25 to 80 centimeter, the buzzer stays off and the lid remains open. The system prints the distance and status every second. All these conditions work together to create a smart, responsive lid system that opens automatically.